better view of what we were just looking at here without all that clutter. And that there is my needle valve siphon jet. That's an air siphon, I guess is what they call that. And I'll show you a cross-section of what exactly is required for one of these things to work the way it does. One of the cool things about building stuff on the fly without blueprints, without planning it out on paper first, is the fact that you sometimes stumble on configurations you would have never took the time to draft out on paper first. If you try to run this with just a straight bore tube, this particular oil and this particular nozzle will not run the way we've seen without this elbow on here. This elbow is absolutely essential to the functionality of this particular burner. For whatever reason, it causes eddy currents in this top area that allow some buffeting and some flame to take place to maintain ignition. I did try to run this thing using this pipe here and was totally unsuccessful. Now maybe had I gassed it up, put a little gas in the oil and heated this thing up for ignition, we might have got somewhere. But I'm not interested in that right now. I want something that's just easy to light and does the job. And this right here, this particular configuration was determined by simply taking a blowtorch and the nozzle in my hand and just kind of free running it. Something I never would have done. Had I drawn this out on paper, it would have been a straight bore combustor, and this would have been annularly aligned inside of that combustor in an annular configuration, and it would not have worked. It would have been a total waste of time. The only reason why I found out how this works is just from messing around with the system in action when it's actually running. The position you see this nozzle right here was also not designed on paper, but observed through testing just by repositioning the nozzle on camera and then examining the footage. So sometimes when you're building stuff like this, drafting stuff out a lot of times can be helpful, but for some of the most important and unintuitive aspects of certain machines, building them on the fly is the only way to go. What we're looking at here is just a control unit that I've repurposed. This is actually, I'm just using this because it has a valve on it. That's the only reason I have this tank hooked up. This is just a siphon canister that I built a long time ago. What happens is you put liquid in this thing and pressurize it, and liquid will spray out of this valve. There's a siphon that goes all the way down to the bottom there, but I am repurposing it because it has this valve on it. So that's where we are there. And this here is a special little injection nozzle that I made. It was adjustable at one point, but I determined through testing that you need to just find the sweet spot that this thing likes and then just go with it. And the reason for that is it just doesn't have anything inside to support the air jet spur. And the position of that air jet spur is very important to the performance of the nozzle. This thing's got a little bit of oil dripping into it, it looks like. Now this burner runs far more efficient than any burner I've built yet. I'm still just in testing phases. That's why there's just a big mess here everywhere. I'll eventually get this thing out in a clear area. I think I'm going to put some heat shielding on some of this stuff and pretty much go with it. This thing is going to be used to burn some more tree stumps out of the ground. It's a lot faster than using a fire. A fire takes days sometimes. And I have all this waste oil, plus I just like building stuff that's awesome. Kind of an addiction. But that is basically just a needle valve with a hollowed out tube through it and a specially shaped end. I'll show you what's actually going on here on the end, because just two pipes inside of each other don't work. I found out the hard way. You have to actually put that divergent nozzle end on this for it to siphon properly. The amount of oil this thing uses is pretty much imperceptible. You can't even see the fluid level dropping, and that's pretty good. I think this thing burns far more efficient. There are some attributes to this burner that I'm not going to exploit. One of the things I observed during testing is the position of this needle inside of this intake port can alter the flame significantly. If this thing's pushed inside of the combustor, say down into here, in this area, the flame burns a lot brighter and a lot hotter than what we've seen there. The only downside to that is it's extremely hard to light it in that configuration. This one here pretty much just lights right up the way it is there. I was going to build a setup that allowed articulation of this jet, but I decided good enough is well enough at this point. I've been messing around with this thing for 2 days, trying to get a perfect nozzle and all that. I'm going to go ahead and post this test though, because some pretty interesting things did happen. I was able to run this thing at about 40 psi's, which is awesome. My other test nozzles would not do that. This thing is just spraying some oil on me here. Cool it off a little bit so it'll quit smoking. The thing runs red hot pretty much. It'll be super easy to clean. My other waste oil burner, this thing here, is pretty much retired. I'm going to probably end up just throwing that thing in the dumpster. It's not even worth salvaging the metal there at this point in my life. I used to hang on to stuff like this for a rainy day, but I'm turning into quite the hoarder, so it's got to go. This thing wastes a lot of oil, a lot of your fire. Okay, so here's what's happening inside of this valve, or inside of this siphon pump, I should say. This is the needle valve, and I bored a hole through that shaft with a small drill bit and inserted a very tiny copper tube. We're talking small, like a little bit tinier than that even, and it's basically just one tube inside of another. And initially I started off where the end of this was just a straight opening like this. Like if this was your pipe. I initially tried it like this because I do have a siphon pump that works like this that I use to pump really nasty chemicals and stuff like that. That's this device here. You can see that the barrel is way down inside of there. Basically blow air through one side. And anyway, that one's a little bit different, but back on the subject, it's configured somewhat like this, but it just wasn't working the way I intended. So what I had to do with it shaped like this, it wasn't working. It would not pump oil. So I took and I bent the end down just a little bit to give you that divergent area where the velocity of the air is increased just a little bit. Now I may be out of scale here. My nozzle is actually about right back in here. Let's pretend that isn't there. And what happens is the air comes out and goes like this. And in that little area there, that little high speed zone, the velocity is increased significantly beyond what just this nozzle here does. And what happens is anything back in here, any air molecules or anything, gets sucked into that vortex, and that causes a flow of oil in this direction. Initially it starts off as air, and any air molecule that may fly this direction just out of its own kinetic energy hits this zone and does not return. Every molecule in this area is just gradually swept away by being impacted by high-speed air molecules. That's what induces the vacuum in an air siphon. And so our oil would come in this way under vacuum induced by the vortex, or the Venturi. This is actually called a Venturi. This is an annular Venturi. I started off with a conventional Venturi tube. This is a Venturi tube indicative of the type you would see in a traditional physics textbook. Basically, you have an oil tube, it's this curved piece, and an air jet flying over the top of that. I kind of bent the end there a little bit to capture more of the air. Now this one did pump enough oil to begin the testing of the construction of this device. But it showed me that this doesn't pump enough oil, that I needed more oil. So I went ahead and I built this, and initially this didn't pump as much oil as this did, and it wouldn't burn at all. So I had to up the flow rate of that by redesigning it. It was kind of a pain in the neck. But anyway, this one sprayed oil very well. It would run that burner, it was just very touchy. However, it just didn't pump enough oil. So that's that. And that's what gave me the idea of building this design here, which is called an annular Venturi. And it works pretty well. The first version of this I did didn't pump enough oil, but it made an awesome little airbrush. You could have painted with this thing. This is very similar to the construction of a lot of airbrush systems you would see for painting also. And that's what we got. So these are basically the two parts of my Siphon atomizer. It's a thin piece of copper tubing here. And this is the pump section. This is the air jet. Now this is made out of an old needle valve, and by rotating the thread setting on this valve, I can move the position of this jet nozzle in relation to the end of the ejector discharge. This is basically kind of like an ejector. I don't know if you know what an ejector pump is, but this thing also happens to be a good atomizer as well. So I'm going to pretty much try and find a sweet spot based on where this needs to be positioned, and hopefully make a good oil burner nozzle.